all. So over here, we will continue with chapter 6. So in this particular lesson, we'll go through two objectives. Number one, that is simplifying log expression involving changing of base. And also, we will want to also talk about how can we solve log equations using laws of logarithm. Now, this is a question that we all have in end of the year exam, question 5. So there are two parts to this question. So first part require us to simplify log changing of base, and part B will require us to solve simple log equations. Now let us proceed. So over here for part A, right, what you observe here is both log equations have different base. Yeah, so we can see we have log 4, base 4, 16. So with this different base, what we will need to do is we will need to apply change of base formula. So to apply change of base formula, as we can recall, what we have will be this. Okay, well, okay, so this is the change of base formula. So for us to change the base, what we will need is see that we will have change to the same base C. And when we do that, notice that the numerator will be B and the denominator will be the old base. So this is how we approach change of base formula. All right. So in order for you to do that, there is another thing to observe as well. When we want to solve this question, we will see that, all right, we will also need to apply laws of logarithm in the process. Now, one of this particular, right, made by most students is to work on both sides simultaneously. Now, do take note in this case, the question that we are dealing with us to show, all right, a particular result. So when we are asked to show a particular result, we cannot work on both sides together at the same time. So what we will need to do is we work from the left-hand side or we work from the right-hand side. Yeah, so with this, we shall proceed. So over here, what we can see is, all right, we have both sides here, like I said. So what we want to do is we will proceed to use change of base formula. So to use change of base formula, let us have the formula with us so that we can refer to it as we go along. So with this, let's proceed. So we will want to apply left-hand side first. So with left-hand side, I will start with log base 4 of x plus log base 16 of x. Now, so over here, I choose to change base. So what you observe is that I choose to change to base 10. So when I just write down LG. So LGX over LG4. So again, if we take a look at the formula, so we want to change to the same base. So when I change to the same base, the numerator and the denominator both is the same base 10. So similarly for the second log function. So from base 16, I change to base 10. Yeah. So with this, let's continue. So once I have done that, I will proceed to, to simplify the log expression. So over here, I'm not too sure if you are able to observe, we are actually applying the third law, that is power law. So based on power law, what we have here is, you will get to see, I change it. We can see that log base 10 of 4, this is actually the same as log, I can rewrite the 4 as 2 to the power of 2. So therefore, with 2 to the power of 2, and then if I apply laws of logarithm, third law, the power law, so I eventually will bring down the 2, then therefore I have 2 log 2. So similarly, I can rewrite 16, in this case, as 2 to the power of 4, because 2 to the power of 4 is the same as 16. So therefore, applying power law, therefore I have 4 log 2. So with this, I combine them together. All right, I put them together, and this gives us the expression as you can see on the screen here. All right, so with this, we proceed. And what I do is, we just need to simply combine the two fractions as a single fraction. Yeah, so once I have done that, I am done. So I equals to the right hand side. So over here, the skill that you need will be by combining the two fractions as a single fraction. So again, you will need your algebra skill. Yeah, so with this, part A is done. So we move on to part B. Now, so as in, before that, so there is alternative method for these questions here. So again, instead of changing both to log base 10, so right now, what you will see is, instead of changing log base 4 of x to LG base 10, I only focus on changing log base 16 of x. So over here, you notice that from log base 16, I changed to base 4. So out of the two bases, right, some of you may ask, how do I know which one to change? So the trick here is you always change the bigger base to a smaller base. Then you will notice that it is easier for you to manipulate the expression later on. Yeah, so over here, I choose to base to 4. So as I continue, so again, I apply the same concept here. I apply power law. So by using power law, I'm able to convert the log base 416 to 2 log base 4 of 4. And if you know the special log base 4 of 4, it is actually equals to 1. So with this, again, I combine algebra skill of combining them as a single fraction. So this is what I have. So combining this together, you notice that I get log LGX and LG4. Some of you may ask, how do I actually get this? So I actually skip one step. So what we are doing here is actually, if I am looking at this expression here, right? What I get is actually, I get 3 log base 4 of x over 2. So with this, right, what you notice is I actually change my log base 4 of x. This log base 4 of x, log base 4x, if I change base, this again will give me log x over log 4. Yeah, so that is the reason why I get this particular term here. All right, log x over log 4. Yeah, so with this, we'll proceed. Then from here, I just again combine or to change log 4 to log 2. All right, to do that, I can simply just, again, using power law, and I can derive to the answer that I want. All right, so maybe I will just write it down in case some of you still require me to not able to see. So basically, log 4 is the same as log to the power of 2. So when I apply power law, so again, I get 2 log 2. Yeah, so therefore with these 2 log 2, I combine it together. That is how I get 4 log 2 over here at the denominator. So with this, we are done with part A. So let us move on to part B. Now part B will require us to use part A to solve the equations. How do I know that I have to use part A? It is simply, all right, because of the word hence. All right, the word hence is given here. So with this word hence, I know that I need to use part A. So with that, I know the result of part A on the left-hand side. I know that it is equals to 3 log x over 4 log 2. So with this, I apply using part A. Now, so another observation that you may make is that you notice from negative 2.25, instead of writing in decimal, I actually change it to fraction. Now, why do I do that? You will see in the next step. So why do I do that? I can actually simplify it. Now, how do I derive over here is simply, if you can make some observation, right? 4 and 4, same denominator, so I can actually divide 4 throughout. Then what I have here is, you can see that the 3 and the 9, they are actually also similar. Also, there's a common factor. So which is, if I take 9 divided by 3, so I know that this will give me 3. So I can actually simplify by multiplying my log 2 on the left-hand side to the right, and this simply derive this particular equations here. Okay, now, so with this, again, I'm going to proceed. I'm going to apply power law. So if we can see, if by applying power law, I can simply move the value -3 to the index. So I get negative to the power of -3. So again, you will see both sides here have the same log function. So again, we will apply equality of log, all right, which is the first method of solving log equations. So by doing so, I know that the term inside both log functions must be the same. So I conclude that x has to be equal to the power of -3, and therefore conclude that the final answer is equal to 1/8. All right, so that is the first method that we can apply. Now there's that is not using this. So another way is by doing this. So that means if I don't change -2.25 into a fraction, I can also do that. So in this case, what I do is I simply move the denominator to the right hand side and multiply them together. So, and then I bring the 3 over to the right hand side. Now, so when I do that, right, this will require another knowledge. So this knowledge that we need, it is simply by the second method. So this second method of solving equation will require us to know how to solve the equation by changing the log form into the index form. Exponential form, it is also known as the index form. So what do I mean by this? Not too sure how many of you are actually familiar with this. Give me a while. Okay, so when you see this, all right, when I want to change from the log form, which is currently here I have is in log form. So I want to change the log form to index form. So you observe that in this case, this is LG. LG is referring to base 10. So this explains why I have a 10 appear over here. So because this is a base, right, base 10. So from a log function here, I rewrite. So now in index form, I have a base 10 here. And then what you have here on the right hand side of the equation, this actually becomes your index. So the moment you are applying here by changing, all right, by changing the log form to index form, I can simply just, from here, this is log form. This is a log form. And I convert it into index form. Yeah. So once you're and then to end off, you just simply use a calculator, right? You can get the answer. It will show 0.125, and 0.125 is exactly the same as 1/8. They are the same. All right. So with this, we explain how we can solve question 5B.